Good morning, ladies and gentlemen, and welcome to our last lesson of the year. We're going to start off with a little bit of revision from our previous lesson. I'm going to talk to you in a little bit more detail about those quadrilaterals. I think some of you struggled a little bit with some of the questions, but for the most part it seemed like all of you had it pretty much nailed. And then we will talk about triangles once more, but that'll be our new lesson for today. So when we talk about quadrilaterals, we know that that is any shape with four sides. Okay, so if we start off with just our main heading, and this will be quadrilaterals, and there are a few different ways that we can classify different quadrilaterals. Okay, and the way that this works is we start off with a quadrilateral, which is a shape with four sides. If it has four sides, you know it's a quadrilateral. And then we start looking at its different sides to tell what type of quadrilateral it is. So at first we look to see if there are any parallel sides. So the first one would be no parallel sides. Okay, if it's got no parallel sides, we just call it a quadrilateral. Okay, so if you're looking at a four-sided shape, you know it's a quadrilateral, but it doesn't have any parallel sides, we just got to call it a quadrilateral. Okay, if it has one pair of parallel sides, one pair of parallel sides, okay, it will look something like that. Okay, and it'll be this side up here and this side down here. Those two lines are parallel. So this has got one pair of parallel sides, and we know the name for that is a trapezoid. Okay, and if it has two pairs of parallel sides, then it is called a parallelogram. Okay, and there are many different shapes or types of shape that we've learned that have got two parallel sides. But the way that this works is we start off by judging them into these three categories. If it's got no parallel sides, it's just a quadrilateral. If it's got one pair of parallel sides, then it's a trapezoid. If it's got two pairs of parallel sides, then it is a parallelogram. Okay, so we start off with one broad category, and we have then got slightly smaller categories. This means that every parallelogram is a quadrilateral, every trapezoid is a quadrilateral, and every quadrilateral is a quadrilateral. But now we've got even more specific ones. We have a rectangle and a rhombus. Okay, now a rectangle is a type of parallelogram, which is a type of quadrilateral. A trapezoid is a type of quadrilateral. Okay, a rectangle is a parallelogram with four right angles. Okay, so any parallelogram with four right angles will be called a rectangle. Okay, so these parallelograms would go like that, and a rhombus is any parallelogram with four equal sides. So this side is the same as that side, which is the same as that side, which is the same as that side. You notice that for the rectangles, it says nothing about the length of the sides. that it has two pairs of parallel sides and 4 right angles. And the rhombus, it says nothing about the angles, just that it has 4 equal sides. Okay, so the rectangle, again, is a type of parallelogram, which is a type of quadrilateral. A rhombus is a parallelogram, which is also a type of quadrilateral. So a rectangle and a rhombus are both parallelograms. They're also both quadrilaterals. Now, the last thing that we've got, which stems from both of these, is a square. And a square is a special shape because it has the properties of a rectangle and a rhombus, which means that it also has the properties of a parallelogram, which also means it has the properties of a quadrilateral. So, because it's a quadrilateral, it has 4 sides. Because it has a parallelogram, it has 2 pairs of equal sides. Because it is also a type of rectangle, it will have 4 right angles. And because it is also a rhombus, it will also have 4 equal sides. And that is exactly what a square is. So a square is actually a rhombus, a rectangle, a parallelogram, and a quadrilateral. It fulfills all of the necessary requirements to be a rectangle. It fulfills the necessary requirements to be a rhombus. It has also got the requirements of being a parallelogram. So a square is just a very, very specific type of quadrilateral. It's a specific type of a rectangle. And what the whole point of this is that these are just different ways to name different types of quadrilaterals, starting with very broad categories and then working our way down to more specific shapes. Okay? So this means that a square is always a rectangle. All right? It just fits the properties of being a square. A rectangle can also be a square, but only if all of its sides are equal. All right? A rectangle is not always a square, but a square is always a rectangle. A rhombus can also be a square if it happens to have 4 right angles, but a square is always a rhombus, because a square always has 4 equal sides. A square is always a type of rhombus. Because a square always has 4 right angles, it is always a type of rectangle. Okay, so I know that the last problem on the assignment from our previous lesson was a bit tough, but I hope that this kind of makes sense of it all. All we're doing is we are classifying quadrilaterals. Okay, and it's similar for the rectangles. It's similar for the triangles, which we can classify on angle, or we can classify on sides, or we could do a mixture of both. Like we can have an isosceles right triangle, or we could have a scalene right triangle, depending on what the sides are and depending on what the angles are. They're just different ways of classifying our shapes. So now that that's done with, we can start talking about our actual lesson for today, and that's how to calculate missing angles inside of a triangle or a quadrilateral. So the first thing we need to know is that in a triangle there are 180 degrees. All right? That means that all of the inside angles, no matter what triangle it is, will add up to 180 degrees. Okay? And this makes calculating a missing angle really, really easy. Okay, so if we said that this triangle had this angle as 60 degrees, and then this one was 70 degrees, you notice that both of them are less than 90 degrees because all of these angles are acute angles. So if this angle was 60 degrees and this angle was 70 degrees, what is the missing angle? How do you think we would calculate that? Well, I know that if all of these angles add up to 180 degrees, then I've got 180 degrees in this triangle altogether. So 180, and I take away the 60 degrees that I have here, I take away the 70 degrees that I have over here, and I will be left with my missing amount of degrees. So all that I want to do is say I've got 180 degrees, I take away the degrees that I already know, and it will have to leave me with my missing angle. Okay, so 180 minus 60 is 120 degrees, minus 70 degrees is equal to my missing angle, and then 120 degrees minus 70 degrees is equal to 50 degrees. Okay, so 50 degrees is my missing angle. And how would I check to see if this answer is correct? Well, if 50 degrees is my missing angle, if I add that to 60 and 70, it must equal 180 degrees. So 50 plus 60 plus 70 is equal to what? Well, 5 plus 6 is 11, plus 7 is 18. Add the zeros in, that equals 180. So I know that the missing angle was 50 degrees. Okay? Now, maybe I could give you a question with two missing angles. All right? Or maybe two angles that I haven't really written, but we could try it anyways. So if I make this triangle like that, and I draw this little half square here, and I make this angle over here 30 degrees. Is it possible to solve that? Well, of course it is. This angle here, we know is 90 degrees because it is a right angle. So I actually have given you the angle. And I know that 90 plus 30 plus my missing value will equal 180 degrees. Well, 90 plus 30 is 120, plus our missing angle must equal 180 degrees. So what do I need to add to 120 to get to 180? Work it out in your head. It's 60 degrees. So my missing angle is equal to 60 degrees. All right, so all we need to do is calculate by subtracting from 180 or finding out what I need to add to my current angles to get to 180 in order to find my missing angle. The next thing we're going to talk about is how to find missing angles in a quadrilateral. Now, a quadrilateral, a four-sided shape, has got four internal angles that always add up to 360 degrees. That angle plus that angle plus that angle plus that angle will always add up to 360 degrees. Okay? Some of the shapes are really easy. If it's a square, I already know that all of the angles are the same. Every single one of those angles will be 90 degrees because a requirement for a square is that all of its angles are right angles. And the same for a rectangle. So if I gave you a square or a rectangle, the problem would be so easy to solve. You know that all the angles are 90 degrees regardless of whether or not I've given you any other angles. But it gets a little bit more tricky when we move to a shape like a rhombus, and this is why we need to learn these properties. If I have a rhombus, I know that my angles are going to be different, but the length of my sides are all going to be the same. And the one thing I know about a rhombus is that opposite sides or opposite angles are equal. So this angle at the bottom here will be the same as this angle at the top, and this angle on the right will be the same as this angle on the left. So if I made this angle 60 degrees and I made this angle 120 degrees, I would then know that this angle is also 60 degrees and that this angle is also 120 degrees, because in a rhombus, the opposite angles inside the shape are always the same. So if I try to calculate if this was correct, I would need to add up all of these angles inside and make sure that they added up to exactly 360 degrees. So let's try that. 60 plus 60 is equals 120. 120 plus 120 is equal to 240. And 120 plus 240 is equal to 360 degrees. So I know that that is correct. But what if I gave you a more difficult example? Something that's a real mind bender, something that's going to really trouble you. If I had a rhombus and I told you the value of these two sides, I said that this is 70 degrees and this is 70 degrees. How could you figure out what these two missing values are? Well, again, we know that the opposite inside angles of a rhombus are identical. So, and I know that all of this adds up to 360 degrees. So, try and figure this out. Pause this video and try and see if you can figure it out before I give you the answer. The way that we would do this is we'd say that I know that 360 degrees are in a quadrilateral, and that's going to be equal to 70 plus 70 plus my missing angle plus another one of my missing angles. So two of my missing angles. So 360 is equal to 70 plus 70 is 140 plus 2 times the missing angle plus 2 times the missing angle. So now I get in a bit of a tricky position. I know that 360 is equal to 140 plus 2 of whatever I'm missing. So how do I get from 140 to 360? Well, I know that I'd have to add 20 to this to get to 160. So I add 20 to get to 160, and then I need to add 200 to that to get to 360. So I know that 140 plus 220 is equal to 360 degrees. So I know that my two missing angles here must be equal to 220 when you add them together. What do you have plus itself? 2 times what is going to give you 220? Well, 220 divided by 2 is 110. So I know that each of these angles must be 110. 2 times 110 is 220. So this missing angle here, the question mark, is equal to 110. My question mark is equal to 110. So I put 110 for this angle and 110 for that angle. And we can again check our answer to see if that makes sense. 110 plus 110, we already know is 220 because we used that to figure it out. 70 plus 70 is 140. 220 plus 140 is 360 degrees. So I've checked my answer, and this whole problem now makes sense. In examples like this, it really is helpful to look at what information you've got. So in this case, we knew what these two missing angles were, and we knew that the total angles needed to add up to 360. I needed to find out what two of my missing angles were, and I can work my way backwards from there. Questions like this are a little bit more tough. They'd be the more challenging questions that I set for you in today's assignment, but I'm sure that most of you will be able to figure it out. And then we also get just our quadrilaterals and our trapezoids that maybe don't have matching angles, and we'll see what we can do with those. If I have a trapezoid, I have two parallel lines, and I have two lines that are not parallel. So I've only got one pair of parallel lines. And in an example like this, it still adds up to 360 degrees, but we don't know any opposite angles are equal, so we can't really use that same method that we used for the rhombus. So you really have to know the properties of your different shapes in order to figure out whether these angles will be, whether opposite angles will be equal, but that will only ever happen in parallelograms. In our trapezoids, it just will not work. So the only questions that we can ask you are to calculate a missing value. So if I have this angle here as 120, this angle here is 50, and this angle here is 70, all degrees, what is going to be the value of this missing angle? Now, I can't just look and say, well, this is 50, so this must be 50. You can see that these two are opposite and they're not the same. All right, so you really have to look at the shape and think, what makes sense in this situation? Can I do those? Would it make sense that these opposite angles would be the same? Well, in a trapezoid, certainly not. But we know that all of these angles need to add up to 360 degrees. So 360 degrees is equal to 120 plus 50 plus 70. Okay, and we don't forget our degree signs. We always put our degree signs. So that means, obviously plus our missing mystery degree value. This means that 360 degrees will be equal to 120 plus 50 is 170 degrees plus 70 degrees plus the question mark. 170 plus 70 we know is equal to 240. So 240 degrees plus our missing degrees must be equal to 360. What do I need to add to 240 to get to 360? 120. So that means that our missing value here must be 120 degrees. Again, this is very similar to some of the problems that we did recently, finding the missing values. I love this type of work where there's a puzzle to be solved and you just need to figure out what information you've got, what information you're missing, and try and figure out what the missing value is. And for a shape like this, it's the same as for any other quadrilateral that doesn't have a specific set of information or a specific classification. Regular quadrilaterals that don't fall under the trapezoids or the parallelograms will also be solved in a similar way to this, because we can't really tell anything about the angles. It's been really interesting trying to teach you guys online, and I'm really thankful to all of you who have put so much extra time and effort into asking questions, asking your parents for help, watching the extra videos, doing the extra questions to make sure that you guys have understood everything we've taught on this online period of teaching. And I'm so proud of all of you who have managed to really apply yourselves and have put so much extra effort into understanding what we've been doing. Please tell your parents a big thank you for all of the extra help that they've been giving you, because without your parents at home helping you out and showing you the right way to do things and helping you with things that you couldn't understand from the videos, because at times it is difficult to understand from just a video. So really go to your mom and dad, give them a big hug and say thank you so much for helping me with all of my work in maths during this online teaching. I hope to see you all again soon. Please come and visit me next year. Come and say hello. I'm always interested in hearing what you guys have got to say and what you're up to and how your maths is going in grade 5. And yeah, just keep well and keep safe. Miss you guys all so much. Have a great day and enjoy your summer break, which is coming up very soon. Bye.